100 subscriber special, outside edition.
Welcome back, everybody.
We could do 200 subscribers.
Do you have 100 subscribers?
I have over 200.
Whoa! So I guess we need 300 subscribers.
Right,
and we'll
exactly.
do
Or
an
maybe I'll do
outside
like a
live
250.
stream.
I'll do a
Yeah,
250.
250.
My
I'll
100
make-
my 100 subscriber special was actually a really good one. It was like the last day of the seniors, like 3 years ago or 2 years ago maybe, and they gave advice to the next couple of years.
Think
It was
there's just
really-
random students out there that actually watch your videos?
There are random students out there that actually watch videos.
Because I know there's
Was
some
anybody in my class the year that we had Jerry?
Jerry,
Remember Jerry?
I remember.
I had this little kid, like just commenting on my videos. His name was Jerry.
Sometimes I don't really.
What was the
sections.
it was the magic
That's
school
so
bus?
funny.
Yeah, that whole conversation. Yeah.
I wasn't in your class, but I remember hearing about it.
All right. Shout out, Jerry, if you're watching. Shout out. Shout out. All right, here we go.
Sub to Jerry.
Sup to Jerry. He had some funny videos. He had he tried to like, wasn't there like a tried to fit like 20 suckers in his mouth or something like that?
That was something.
He
Yes.
like gagged on it or something.
I'm stuck right now.
All right. So we've learned about the R value, the correlation coefficient for samples. We learned about rho, which is basically the R value for populations, right? Now what we're going to be looking at is, okay, how big of an R value is significant, right? How big of an R value, how big of a correlation coefficient, how big does a correlation coefficient need to be actually be what we would call significant at any given significance level? We can do this by kind of making or using this table. This table is not in the yellow sheets. I'll have to give you a copy of this on the test, or maybe you can memorize it, Kylie, if you want to memorize the table. That would be a challenge too.
That wouldn't be boring.
That would not be boring. This is in your book. If you ever lose it or want to see it, it's called Table 11 in Appendix B. To do this, we use Table 11 in Appendix B. N stands for the number of pairs of data. If the absolute value of R, your sample correlation coefficient, is greater than the critical value, then there is enough evidence to decide that the correlation is significant. Otherwise, there is not enough evidence to say that the correlation is significant. So, for example, I believe I still have this in my table here, right? 1, 3, 5, 6, 8, 7, 12, 13, 16. All right, let me go back out here. Stat, calc, linear regression, enter. There we go. So here's my R value. Okay, my R value is 0.996. What is N in this case that I'm going to be looking at in the table? N is 5, right? 1, 2, 3, 4, 5. So N is 5. The number of pairs that I have is 5. Not total number of pieces of data. Number of pairs that I have is 5. The R value is 0.996. Everybody look at your table. See, N is 5. Now, they only list off alpha 0.05 and alpha 0.01. So a 95% significance, 95% confidence and 99% confidence. Is this R value significant at both of these levels? Yeah, because I see 0.878 and 0.959. Okay, I see 0.878 and 0.959, and that's for the alpha 0.05 level and the alpha 0.01 level. And Brandon, all I'm doing out there is just looking at the table, which you don't have. You can find it in Table 11 in Appendix B in your book, though. But that's what we see here. Alpha 0.05 is 0.878. Alpha 0.01 is 0.959. So therefore, I can say because my R value is greater than both of these things, I know that this is a significant correlation. Okay? We can say that this is a significant correlation because my R value is greater than those R values in the table. Okay? At both the 95% strength and the 99% strength. Okay. All right. So we can talk about significance using this table, but we can also use hypothesis testing. Hypothesis testing for a population correlation coefficient. Now, how do we set up our hypothesis test? Well, remember that same rules apply for null and alternative hypotheses. The null hypothesis is always going to have the equality statement, and the alternative is not going to have the equality statement. But I'm going to have 3 separate instances because my R value could be positive, could be negative, or we could just be asking about it being right on, right? We could have a less than, we could have a greater than, or we could have an equal to. Now, remember that if I'm making a test about a population, right? We were always talking about mu because that was the population mean, right? If I'm talking about population correlation coefficient, what variable am I going to be using with my hypotheses? Am I going to be using mu? No. I'm going to be using rho, right? That fancy looking P, right? I'm going to be using rho. Now, I could either say that rho is going to be greater than or equal to 0, rho is going to be less than or equal to 0, or rho is going to be right on 0. Okay? Now, the reason I am putting it like this is because then I can say, in the alternative, rho is going to be less than 0, rho is going to be greater than 0, and then rho is not equal to 0, right? I hope to reject my null, right? I hope to reject my null because what is this saying? If my null is that rho is greater than or equal to 0, I am saying that there is no negative correlation. Okay? There is no negative correlation. And if I can reject that null hypothesis, then I can basically kind of accept my alternative, right? We don't really say that, but when we reject our null, we accept our alternative, and our alternative is that there is a negative correlation. Okay, there is some sort of negative correlation. So if you want to show that there is a negative correlation, you use this setup. If your aim is to show that there is a negative correlation, you want to have this setup. So rho is greater than or equal to 0. Therefore, in my null, and then in my alternative, that rho is less than 0. Now, if you wish to show that there is a positive correlation, that means my claim, the alternative, needs to be rho is greater than 0. So this says that there is no positive correlation, that rho is less than or equal to 0. So if I want to reject that null, this would be that there is a positive correlation. Right? Rho is greater than 0. My aim is to reject the null, so therefore accepting the alternative. Now, what does this third one state then? Well, the third one just states that, okay, if null is rho is equal to 0, what happens when my correlation coefficient is equal to 0? Is there any sort of correlation? No. This says that there is, get out of there, no correlation, right? No correlation. So therefore, the complement of that would be that there is some sort of correlation. Does that make sense? If you want to show that it's neither positive nor negative, you just want to show that there is some sort of relationship, then you use my third option down there where the null hypothesis is that rho is equal to 0. Therefore, the alternative is that it is not equal to 0, which means that there is some sort of correlation. It's not a statement that it's positive or negative. It's just a statement that's saying that there is some sort of correlation going on. Okay. All right, so those are our 3 options for hypothesis testing for rho. Now, what is our test statistic then? Our test statistic looks a little weird. Take a look at that. Again, this is on the yellow sheet as well. It's still a t-score because we're talking about a sample, right? Whenever you're talking about a sample, you're talking about a t-score. A t-test can be used to test whether the correlation between 2 variables is significant. The test statistic is R, and the standardized test statistic follows a t-distribution with, look how many degrees of freedom? N minus 2 degrees of freedom. Why? Because there are 2 sets of data. Because you're comparing x and y together. So we have n minus 2 degrees of freedom, and there is our test statistic. Let's kind of analyze what all these things are. So the t-score is going to be equivalent to r. Oh, that's our sample correlation coefficient, right? That's what we get from our calculator. R divided by the square root of 1 minus r squared over n minus 2. Now, that square root of 1 minus r squared over n minus 2, that is actually the standard deviation of r. The standard deviation of r. The square root of 1 minus r squared. So 1 minus r squared is always going to be turning out positive, right? Always going to be turning out positive because r is always going to be a number less than 1. So 1 minus r squared, the deviation away from 1, divided by my degrees of freedom, n minus 2. That is the standard deviation for r. Square root of 1 minus r squared over n minus 2. That's going to tell us our t-score. And then we can use our t-table to see whether and our level of significance, to see whether we can accept or reject the null. And the accepting and rejecting the null is there a significant correlation? Positive, negative, or just some sort of correlation. All right, let's go for it here. Using the following data, can we support a claim of a positive linear correlation? Let alpha be 0.05. Okay, so let's first, like we always do, let's set up these hypothesis tests in the exact same way that we always have. Let's set up our null, and then set up our alternative. Okay, if my claim is that I have a positive linear correlation, where is that claim going to go? The null or the alternative? Where do all my claims go for these? In the alternative. They always go in the alternative, right? So therefore, if I want to claim that there is a positive linear correlation, that means in the alternative, I'm going to say rho is greater than 0. Because it's a positive linear correlation. That's my claim, is that rho is greater than 0. Okay, therefore the null is going to be that rho is less than or equal to 0. Right? I am trying to support my claim. And if I'm trying to support my claim, it must go in the alternative. Now, let's figure out what we know and what we don't know. What is my n value in this case? 6. How many degrees of freedom do I have? 4. Okay. Now I have to figure out my R value, because to figure out my test statistic, I know n, I need R. Well, I just go in my calculator. Let me go back there, excuse me. I go in my calculator and I put it in my lists. All right, clear down. All right, we got 1, 3, 4, 5, 9, and 10. 9, 15, 17, 22, 30, and 35. And I go back out to my home screen, stat, calc, 4, enter, 0.8046. I don't care about my equation. I only care about my R value. Seems a little low, is that right? 0.8. I had 0.99. Uh-oh, did I screw up somewhere? 1, 3, 4, 5, 9, 10, 9, 15, 17, 22. There we go. Okay, run that again. There we excuse me. There we go, 0.9938. So R is 0.9938. Did I round that correctly? 0.99, yeah. Okay. 0.9938. I always go out to 4 decimal places with my R value. Okay, let's create our rejection region real quick. Before we run our test statistic, let's create our rejection region. And for that, we need our t-table. Now I'm going to go to the t-table here. I look at my degrees of freedom as 4. And is this a one-tail or two-tail alpha?
It's a one-tail.
Oh, it's a one-tail, right? It is a one-tail alpha 0.05. So I'm going to go one-tail alpha 0.05 with degrees of freedom 4. And I see the t-score 2.132. 2.132. So my critical value is 2.132. And I'm setting up my rejection region, right? So if my critical value is 2.132, is this a right tail or left tail test? This is a right tail test. So therefore, I'm going to say my rejection region is if t turns out to be greater than 2.132. Because again, think about your bell curve. To reject, it needs to be in that area if it's a right-tailed test. So my t-score needs to be above 2.132 to be able to reject my null and therefore accept my alternative. Let's figure out what our test statistic actually is then. So our t is going to be equal to, I think I know this. This is r over square root of 1 minus r squared over n minus 2, my degrees of freedom. Okay, r value is 0.9938 divided by the square root of 1 minus 0.9938 squared over 4 and minus 2. Let's plug. What's wrong? Oh, hey. Let me finish this problem. Why don't you just kind of sit up at that back table? Sound good? Okay. All right, so we got 0.9938 divided by, and then I'm going to put this in parentheses, the square root of, I've got to put this in parentheses as well, 1 minus 0.9938 squared, that's the top, divided by 4, and my parentheses. 7, whoa, that seems way off.
You forgot parentheses.
Did I really?
I think so.
I think I did too. No, that's actually right. 17.88. Okay. Did my t-score come out to be bigger than my critical value?
A little bit.
Yeah, a little bit. 17.88 is greater than 2.132. So therefore, I can, do I reject or accept? Or I'm sorry, do I reject or fail to reject? Reject. No, I reject.
You rejected?
Because my t-score was bigger than my critical value because it was a right tail. So then I can make my statement in the end that, well, what was my statement? I can support the claim of a positive linear correlation. Okay. I can support the claim of a positive linear correlation. Sound good? Okay. One last thing, and actually I'll finish up the notes with this. The difference between correlation and causation. The difference between correlation and causation. You just have to be very careful when you talk about correlation and causation. Again, I actually get to discuss this with my Algebra 1 students pretty soon when we start reviewing for the OST, because they make a big difference between correlation and causation and in the wording of the two. Does a strong correlation indicate causation? No. No. A cause and effect relationship is not a correlation. I'm sorry, excuse me, I said that backwards. A correlation does not mean a cause and effect relationship. However, does a cause and effect relationship indicate a correlation? Yes. Yes. So causation indicates correlation because they have to go together, right? If one thing causes something else to happen, well, then they must correlate together, right? If buying movie tickets, buying more movie tickets causes your price to go up, do those things correlate together as well? Yeah, they've got to. It's got to be like a perfect correlation, right? But just because two things correlate together does not mean they cause one another to happen, right? So there are 4 possibilities you must consider. The cause and effect relationship, a reverse cause and effect relationship, the relationship caused by a third variable, and the relationship is a coincidence, okay? First thing, cause and effect relationship. If there is a cause and effect relationship, there will be correlation, okay? If there is a cause and effect relationship, there must be correlation. Reverse cause and effect relationship. You know, that's kind of like saying, if there's a reverse cause and effect, what do I say in my notes actually? I have nothing written down for that. A reverse cause and effect relationship. What do they mean by that? Reverse cause and effect. I think that just means that if things correlate together, that does not necessarily mean they cause each other. Relationship caused by a third variable, and that kind of goes hand in hand with the the idea of just because they correlate doesn't mean they cause. Something else could be happening to it, right? There could be a third variable that or other variable happening to the relationships to make them look like they're correlating together. Like, for example, you think about, I'm trying to think like, okay, test scores and you can kind of think about it this way: homework grade and test score. Homework grade, because if you're completing your homework more, that probably means that you are a better student, and if you're a better student, that probably means that you are doing better on your quizzes and tests. I'm trying to say. Or the possibility that the relationship is just a pure coincidence, and now statistical analysis can kind of take away coincidences. You can kind of analyze coincidences, because the more you study something, the bigger your n values get. The more people you study, those coincidences tend to drop. Okay. All right, that is the notes for today. I want to let you work on the rest of the period for this assignment, and then we can be done with that section.